In this session, we'll do an example of reinforced concrete beam. It's given, the question says design RC beam, reinforced concrete beam, given the maximum bending moment is 825. It says use steel ratio 1.5%, and the width of the beam is given as 20 inches, so this is not up to us to decide. It is given as 20 inches. And the strength of concrete FC prime is 4000 psi, pound per square inch, and the strength of the steel is Fy is 60,000 pound per square inch. So before we start to do anything, we need to write down the equations. That's what you should always do. The equation of design: A is equal to area of steel, Fy 0.85 FC prime B, and this is relevant to this equation. Always these equations used together: 0.9 AS Fy D minus A by 2, and then the steel ratio is area of steel divided by B and D, and then we have the mu equal to Ru BD square. And if we are given, because this is already given to us, so we're not going to use mu equal to Ru BD cubed divided by 2. These are the equations that we need to put in front of us before we start to do any work. So here, before we start the answer, so the answer here. Design, always keep in mind, design means you need to define B, you need to define depth, and you need to define the area of steel. And this question, the B is given to us, so we need to decide D and S, the area of steel. So take a good look at the question here and see which equations we should be able to use. So if you look at the first equation, this one, like I said, this one always serves this one because this will be used here, A. So this is why this is to serve this. These equations work together, let's say. So if I would like to use this equation to calculate D, area of steel is not known to me, and B is given. I can calculate A, that's fine. But when I come to this, I know A, I know M, I don't know D, so D and AS are both unknown, so I will not be able to use these two equations. That's why these two equations are not something we'll be using. Okay, let's move to this equation. And we said, if you remember in the first, you put a star here and a star here. Means if you know the value of steel ratio, you should be able to know the value of Ru. That is because of the tables. So let's take a look at the area of steel here and see. The steel ratio is 1.5%, so that is here given. So I know the area of steel ratio. I know B, I don't know AS, and I don't know D. So this is also not possible to use. Okay. Let's take a look at this equation. This equation, mu is given as 825. Good. And Ru is I can get Ru because I know steel ratio. I can go to the tables and get them. B is given, so the only unknown is D. So this is the equation I should be using. Okay. So we'll start with that one. So we'll say mu is equal to Ru BD squared. This will be my equation. So now mu is 825, and keep the units with your calculation because this will make a huge difference. If you don't use the appropriate units, you will not get the correct answer, and it will be wrong, of course. Is equal to Ru, which is unknown. B is 20 inches, and D is also unknown. So meaning that I need to get the value of this guy. from tables. So for steel ratio of 0.015, the RU value is equal to how much? So let's go to the tables. We have, so keep in mind we have concrete 4,000 and steel 60,000, okay? Because we need to know this from tables. So I'll look for 4,000 and 60,000. So let's go down. 3,000. So here you go. This is 4,000 concrete and 60,000 steel. And the steel ratio is 0.015. So 0.015 will be, this is 0.015. So meaning the steel ratio is equal, the RU is equal to 703, right? And the units are in PSI, keep in mind. It's PSI, the units here. So in table, let's see what the table number is A26B. So it is equal to 703 PSI. And that is from table A26B. Just double check that. A26B, okay. So now I know the value equals 7. So I will use it here. So I'll say, I'll use it. So 825 kip foot is equal to 700 pound per inch square. That's what PSI means, multiplied by 20 inches, multiplied by D. So D is the only unknown to us. So D square, of course. D square is equal to 825 kip foot divided by 703 pound per inch square, 20 inch. So we could do the cancellation here. So this inch and this inch square, we have inch here, but you see we have kip and foot, we have pound, here and we have kip here. So we need to keep them same unit, and we have inch here, and we have feet here. So I need to convert this into pound and inch because that is the unit of. So to convert this into pounds, I need to multiply by 1,000, and to convert this into inches, I need to multiply by 12. And the answer is equal to 704.55 inch. That is square, because the D is square. So the value of D is the square root of and is equal to 26.54 inches. So we'll round this up to 26.75 inches, just quarters. So that is the effective depth. So we calculate the effective depth. Now we have the depth also calculated here. So what's left for us is the steel area. So for steel area, we'll use this equation. So steel ratio is equal to area of steel divided by B and D. That makes area of steel is equal to steel ratio multiplied by B multiplied by D. Steel ratio is 0.015 and B is 20 inches and D is 26.75 inches. So the answer for this is equal to 8.025 inch square. Now this is what we need for as a total area of steel. Of course, we can have to choose a combination. To choose a combination, we have to go to a table 829. So table 829. So here's the table 829. It says area of multiple reinforcing bars. So we need 8.025. So 8.025. This this is close enough. This is 8. This is 8 square inches because this is the unit, right? So this means I'm using number 9 bar and 8 bars number 9. 8 bars number 9. That's the meaning. And well, you might ask, what is number 9? So for numbers, you can go to at the beginning of the chart here, which tells you here. So it says if you say number 9, it means the diameter is 1.125, and actually this is 9 divided by 8. All of these, for example, number 3 means 3 divided by 8. An inch is the diameter. For number 4 is 4 divided by 8, which is half an inch diameter. Number 5 is 5 divided by 8, an inch diameter, and so on and so forth. So number 9 is this, the meaning of it. Of course, the area is also given for this one. So back to table 829. So I'm using 8 bars number 9 here. I'm using 8 bars number 9. Okay, will give me 8. So I'll use, so it says use 8 bars number 9, and that is from table 829, and this will give me an area of steel equal to 8.0 inch square. It is close enough to the calculated one, which is 8.025 inch square. So I'll say this is close enough. Close enough. Enough to use. Good. So I got now also the area of steel. So I say this is done. Now we need to recalculate double check what we did here. So go back here. Now I have 8 bars number 9. 8 bars number 9. Will they fit into this width? So I need to see if this will fit into this width. We can learn this from table. There's a table which is called 828. So we go to table 828 here. It says B minimum width needed. So I am using 8 bars number 9. So the intersection will be eight bars number 9. It means that I need 21 inch width, and that is not what I have. I have only 20 inches, so this is more than. So go to table 828 to check the width. And the width is here is we need 21 inches to fit all 8 bars into one row. But I can split. This means that we need to split the reinforcement, the rebars, into 2 rows. Now, to do so, we need to calculate how much is the cover now, because by default we can use 2.5 inches as a cover, but because we are using 2 rows, now we need to find a way. And here is an explanation for this. If you have more than one row, of bars, this is the formula to calculate the cover. The formula says 1.5 inch, and that's from the building code for American. It says you need to use, this is what we need to use, 1.5 inch and clear cover, and there is also the thickness of the stirrups. These are called stirrups. Okay, and this most of the time they are used as a 3/8 of an inch diameter, so they are small. And then you have the diameter of the bar here, and then half of the distance between these 2 bars, which is half of the diameter of the bar. So this is the explanation for the equation. So you need to use this equation for the calculation. Okay, and this is standard. So whenever you go 2 rows, you have to use this equation. So let's go back. So we need to calculate now. We need to calculate the cover to know exactly how much is the total depth. So recalculate. Calculate the depth. Sorry, calculate the cover. So use this equation, which is cover is equal to 1.5 an inch plus 3/8 of an inch plus the diameter of the bar plus half of the diameter of the bar, equal to 1.5 inch plus 3/8 of an inch plus number 9 is 9 divided by 8 an inch, and half of it is half of 9 divided by an eighth of an inch. So the cover is equal to 3.56 inch. So it means the total height of the beam is equal to the cover plus the D, which is 3.56 inches plus 26.75 inches, and is equal to 30.3 inches. So we round this up to 30.5 inches. That will be the depth of the beam. Okay, now we did calculate all of these elements, but we would like to know, by using this combination of bars and this depth, suggested depth, how much we are getting for the bending, because the criteria is the bending moment, how much the suggested design will be able to carry bending moment. So let's do for this one we need to, again, the equations that we had, one of the equations has a E equal to area of steel Fy divided by 0.85 Fc prime, and this will serve this equation mu equal to 0.9 area of steel Fy d minus a by 2. So I need to use this equation to see how much is the actual resisting moment of the beam. So I start by calculating A is equal to ASFY 0.85 Fc prime B. Of course, use the actual reinforcement. The AS is the actual reinforcement, which is 8.0 inch square. Is not 8.025 square, because that is the calculated one. Multiplied by the Fy is equal to 60,000 pound per inch square divided by 0.85 multiplied Fc prime is concrete strength, which is 4,000, again pound per inch square, and B is equal to 20 inches. So let's do the cancellation for this is pound per inch square will go away, and this inch and this inch is inch. Sorry, so I'll be left with 7.06 inch. So now apply this to the moment. Mu is equal to 0.9 AS Fy d minus a by 2. So 0.9. Area of steel is again 8 inch square, and Fy is equal to 60,000 pound per inch square multiplied by depth is equal to 26.75 inch minus A is equal to 7.06 and divided by 2. So mu is equal to 10,000 that is pound inch. So we divide this to convert this into kips. We divide by 1,000. To convert this into feet, we divide by 12, and this is equal to 835.9. that is kip foot. And this is why we converting this to kip foot, to be able to compare it to the required moment. This beam can carry 835 kip foot, which is greater than what was asked for, 825 kip foot. So this is okay.